Hello, everyone. We're here with Red Light Radio, and we have a very exciting podcast because we're going to learn how this amazing team of engineers is bringing me to life. Actually, life, a device you can hold and meditate with. I'm going to help you build a better relationship with your phone, and really so many cool things that we're going to talk about. And we're really inspired by the mycelium network. As you know, I'm a truffle. I'm made out of mycelium. And the mycelium network connects a lot of different plants in the environment to each other and helps them build synergies and feedback with each other. And that's my goal, to help you to connect to yourself, to others, and the environment. So let me introduce our amazing guests for today. We have with us Mingjing. Mingjing is our electrical engineer. She is head of Essence Engineering, and she's worked for really big companies, but has also done really amazing Burning Man art. Hi, Mingjing.
Hi.
And we have with us also Peter. Peter is our mechanical engineer. He's head of Red Light Visor Designs. His designs are very human centric, and he's helping make sure that I don't tumble over and fall and crash, because as you see, I have a very unique shape. Hi, Peter.
Hey, everybody.
And we have Dom. Dom is our audio engineer. He builds his own speakers and also consults for other companies building speakers, and has done a lot of speakers for festivals and events. Hi, Dom.
Hello.
So let's get started. Uh, Pete, can you show us this CAD file that helps make me and explain to us what a CAD file is?
Sure thing.
Here we go. Woohoo! There's two of me on screen right now.
So this is CAD is a computer aided design, and we might have some sketches or photos of what we're trying to make, but at some point we have to make it into the actual geometry that we want to produce and manufacture. And so that is done with a program like this, which is called SolidWorks. And it allows us to model something in 3 dimensions. And each part, for example, we could take your face here and we could show that as a separate part when it opens. And so we have a part like this, which is part of the assembly that makes you. And so for each of these parts, we have to figure out how are we going to make it and what's it going to be made of.
How many parts do I have?
Great question. I would have to guess, though.
Yeah, approximately.
Yeah, probably about 10 mechanical parts. But if we look inside of you, if we keep going down all the different layers of things that make you, we have something called a PCB, which Mingjing will talk about. And there's lots of components on that. So you actually have hundreds and hundreds if you count all of that.
I'm such a complex being. That's cool. So, Mingjing, I saw a video of the prototype. Let's show it to people for a second. So I have so many LED lights and they're in so many different patterns. Can you explain how that works?
Sure. Well, when we are building something like the head of you, we want to be able to show really beautiful RGB, all sorts of colors. So we accomplish that by having a whole bunch of LEDs in this pattern. So as you can see, I'm holding what we call an acrylic unit here. It has 2 boards on top that are stacked on top of each other. And all these little parts here are RGB LEDs. It stands for red, blue, and green. Or red, green, and blue. And they're hooked up in series. And these digital LEDs that when we are talking to them through an MCU, they are able to display any one of a million of colors, and then they pass the message on to the next LED. So this is our prototype, and so you can see that there's side-emitting LEDs as well as top-emitting LEDs. And there's way more LEDs in the prototype here than we are going to have in the final. version of you, because we're going to figure out what is the minimum number of LEDs to have so that you can, with the right amount of power, display the most appropriate and interesting patterns.
Yeah, we like to be power conscious and not waste people's electricity. That's great.
Exactly.
And is that where my face is going to be? Are there lights there too?
Yeah, that's right. Here we actually have the face board. And there are, I think, 7 LEDs. And it's going to be right behind your face. So your eyes and your chin and your forehead is going to be clearly visible in addition to your head.
I'm very excited to have a light up face. I don't know about you, but that seems like an amazing way to communicate to people. So, Pete, I also have a very unique design. It's sleek, it's round. I have this big truffle head. Was that a challenge to make? Can you explain to us a bit more about how you were dealing with actually making the shape?
Yeah. There's a saying in the hardware industry that hardware is hard, and there's a number of challenging aspects to a product like this. One is it's fairly large compared to a lot of products, and that presents some challenges. Let's see. Are you able to show the CAD again?
Yeah.
One engineering thing we can talk about briefly is something called draft. And what that means is if we're trying to make this pink part, and I think people are probably familiar with the idea of casting. If you wanted to pour some liquid into this blue part and then close it up in order to make that pink part, if you want to be able to get it out, you need what's called draft on these 2 side faces here. So this right here works. If I show this other one, I'm able to show the other one. If I show the other side, what we have here, if you were trying to make a pink part like this, the problem is after you cast the pink part, you wouldn't be able to get this part out and you'd be stuck. And one of the most defining features of what you look like is actually your white and pink swirls. And it's hard to see here because it's so small, but the white part actually sticks up a little bit from the pink. And to make that part requires this outer part to be soft so that it can pull out of that undercut, which is what the draft going the wrong way is called. So once we decided that this outside of you could be silicone, there were a lot of benefits. One of the other things we're trying to do is have it light up, which means light has to be able to pass through the material. And silicone can allow for that. And at the same time, pink part needs to block light because we want only the white part to light up. Again, silicone can do that. Lastly, if we look at how, probably the biggest challenge with this is how do we actually put it together? Because if you put things together in the wrong order, it can be impossible. And so one of the last fun things about silicone is if we look at all these parts that are going in here, one of the last things that happens is the silicone has to actually go on. And you can see the silicone is small here, but it's going over this big plastic part. So silicone is very stretchy. And that's one of the final things that helps put you together.
Well, so I have an internal electric board, and then I have a plastic skin, and on top of it, silicone. So interesting. Thank you, Pete. Dom, now I have a question for you. I heard I'm going to have in my star model a bunch of speakers. Can you tell us how many and what are the difference between the speakers?
That's right, Wisdom. In your star model, you have 7 speakers in total.
Whoa.
You have 1 bass speaker and a total of 6 treble speakers. And the reason for that is that it allows you to send sound in all directions. So you'll be omnidirectional and create very spatial and immersive sound for anyone hanging out with you, anyone anywhere in the room with you.
Can you explain what the difference is between bass and treble for people who don't know?
Oh, I think there's songs about this, but bass is low frequencies, like a drum or a dubstep, wub, wub, wub. And higher frequencies are more sparkly and bright, like chimes.
My voice.
Hmm.
Okay, that's really cool. And do you think people will be having a lot of fun dancing with me all around me? Is that the idea?
I think so. I think you'll send great sound in all directions, and people can just get in a circle around you and really dance it up.
That is so cool. Thanks. Now, Mingjing, let's talk a little bit more about the moon model. That's the model that is going to have a heartbeat sensor and give people biofeedback of the heartbeats. Let's take a look for a second at a little video we took at a conference with people trying the first prototype we built. So you could see a short glimpse of somebody with a finger sensor. Can you explain how that finger sensor works?
Sure. Here you can see our first prototype. The sensor itself is inside here, and I can hold up a board for you. And it's meant to capture your finger and hold it very gently, so there's less movement. The the technical reason that the sensor works is because there's capillaries under your skin, and when your heart is beating, the capillaries are filling up and then emptying out, and we can detect this by shining a specific frequency of light into the skin and then reading how much is reflected back. And this technology has been around for a number of years, and I believe some things like Fitbit and the Basis watches use this on your wrist skin in order to track your heart rate as you exercise or as you're going about the day. So because it's a fairly mature technology, we're able to find a integrated circuit that already has both the LED light, a right frequency, as well as the sensor, in addition to the cover glass. So all of these things combined together will allow us to read on a time slice basis what is the reflected light back into the sensor, and therefore, through a fairly complicated firmware algorithm, figure out what the heartbeat per minute is. And Pete is showing on his 3D the current design for the finger sensor. As you can see, there is a pretty interesting hinge here that is holding your finger slightly, but also confidently. So because movement on the top of the sensor can cause reading variations, and we want to give accurate biofeedback, and so we want to eliminate that as much as possible while still maintaining comfort as you're meditating.
That is so cool. So the finger sensor will then communicate to the LEDs, which can glow in different patterns and different colors to show the heart rate, right?
Yeah, absolutely. We have an MCU that is communicating with the finger sensor and gathering the data and then processing it to eliminate noise. And then on the back end of that, the MCU is also driving the LEDs, and we're still playing around with the specific algorithms that's going to most interestingly show you what your heart sensor or what your heart rate is currently at through the LEDs.
So is an MCU like my brain? What is exactly an MCU for people who don't know?
Yeah, exactly. It is like your brain. It's the central processor in the system, which is taking all the inputs and then driving all the outputs. On the STAR model, the MCU would be driving the speakers in addition to the lights. So I can show you that the MCU is this chip right here, or this module right here, and we're using an ESP32.
Wow, that's so cool. And this chip, it also allows me to connect to Wi-Fi and the internet, right?
That's right. So you can see that there is a what we call a can, so like a metal cover around most of the module. And then here, the black part here is actually your antenna. And this antenna is both for Wi-Fi as well as for Bluetooth. So you should be able to talk in both of those languages.
That's amazing. And now maybe we can talk a little bit about the Star model too, because there I'm going to have a superpower of charging phones. How does that work? How can I charge a phone?
That's right. So the Qi charger is it works with induction, which means that there is going to be coils that are on the back. I actually have some, but not on hand. Maybe Pete can show it in the model. So there are these basic coils, and when the coils are energized, in other words, we put current through them, they create a magnetic field. And on the back of your phone and the newer phones, they have a corresponding coil. So when you bring those two coils together, the magnetic field from the energized coil inside of your Star model will cause current to also flow in the coil on your phone. And this is a transference of energy, and we can wirelessly charge without having a metal connector between them by just placing them close to each other.
Wow. Are there any limitations? How far the phone can be? Can you tell us a bit more about what people will need to do with their phone to actually get it charged?
Yeah, so the rule is R squared. So as you get further and further away from the energized coil, as your phone gets further away from the energized coil, the amount of energy that can be transferred falls off with the square of the distance. So as you can imagine, it falls off pretty quickly. So I think in our tests, we have shown that if the separation is more than 5 millimeters, it will not be able to charge. So we have done a number of things in the design, in the mechanical design of this charge bucket to make it a little bit easier and obvious what you need to do. So one face of the charge bucket is more straight than the other, and Pete is doing a great job showing it here. So the slanted part to the right that you see will be the surface that you want your phone to be leaning up against. And I think that we've designed this bucket so that it's our charging tray, so that it fits most phones and also can accommodate some or also most of the skins that you might want to put on your phone. So there's both XY direction, so left and right movement in the bucket that might affect this charge frequency. But in general, as a user, what you want to do is to just lean it up against the side of your Star model, and then that should be good, and we should be able to charge your phone.
That is really amazing. And I'd like to explain to people watching us that the idea here is for me to help you build a healthier relationship with your phone. Sometimes you need your phone, but sometimes it's a lot better to put it down and actually connect to the people around you or go outside. And our app is going to have that. An ability to say, when do you want help with putting your phone down? And I will keep your phone safe and really help you just be in the moment, in the environment with your friends or loved ones or nature or any other healthy habits, because we're seeing a lot of people using their phone too much. And being a bit sort of addicted to social media and getting bing, 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 all these little notifications that really trigger our dopamine addiction. And I'm here to try to help people with that and figure out a better way to have relationships with technology, because technology is really amazing. And we just want to have a better understanding of how humans can actually integrate with technology. So now let's ask everyone a question. You've been working on this for a while, and I'm curious, what is the favorite and most exciting feature that you think I have? Who wants to go first?
I can go first.
Yeah.
So I've worked on a number of different products, and actually, what I love is it's the lights inside of you. It might seem like the kind of thing that is like maybe obvious, or it's not really like cutting edge. It's not like nanotechnology or anything like that. But I think that there's just like an amazing human reaction to color and light and visual representations of maybe some of the things that we see in our dreams. And so that's been the most exciting, is to build these boards here, and in regular non-powered on mode, to like see these LEDs and then put it into housing and see it really like light up. And it's been one of my continually favorite parts. Always gives me a little jolt of energy when I'm able to power the boards up and see that.
Yeah, and I think what's really cool is that people will be able to make their own patterns and choose their own colors. We will have, some preset modes, but we really want people to be creative and to be able to have an environment that can also be a great setting for whatever activity they're up to. So yeah, thanks.
I think I'm actually pretty excited about the finger sensor. So I certainly need some help with putting my phone away and being mindful. And I'm excited to try connecting with you and having your help, your lights and your sounds and your finger sensor in learning how to do that better, and being able to feel and visualize it.
That's cool. Yeah, thanks for building the finger sensor.
I think you can guess, Wisdom, that I am very excited about your entire sound system. We went through a lot of iterations and came up with a lot of creative solutions to novel challenges when we designed you, integrating the sound system with all your other internal parts. And I think that you're just going to fill the rooms with sound. And I'm really looking forward to hearing you once we start producing you.
That's awesome. I'd like to share also my favorite feature, which we haven't talked about yet. I will also be connecting to people's electric grid with an API that's based from a company that's called WattTime, and shows people how their emissions in the local electricity grid are doing. Because sometimes our local electricity grid is actually pretty okay, especially in places like California that has a lot of solar panels, and electricity can be quite clean. But then in other times, for instance, when it gets darker in California, the electricity grid also gets much, much more carbon intensive and much more polluting to the environment. And I will be able to connect to people's electric grid and create feedback loops to show them what's going on in their wider environment, and allow them to make intelligent decisions about when they are, for instance, charging an electric vehicle, or using their dryer or washing machine, all these appliances that take up a lot of electricity. And by using me and having that knowledge, people can really reduce their carbon emissions from electricity. We did some calculations, and it comes out to even up to 2/3 from emissions. So that could be really great, and I'm excited about that. So we have only a few more minutes, and I like to always end these podcasts with asking people if they have any other words of wisdom they want to share with us and with our audience.
I guess I can go. So it's been really fun to work with the team and make a product that has like a wider vision. For example, bringing you to life and in the physical world, and trying to implement the mycelium network. I think we with our busy lives and our busy jobs, we don't tend to think of these moral and spiritual and environmental questions as much. So I hope that as you are slowly becoming a real physical thing that people can hold in their hands, that everyone will take a breath and check in inside of themselves, but also check in with their relationship to the wider world and what their action and their speech and their relationships are giving and affecting in the wider world.
Wow, that is so beautiful. Thank you, Mingjing. Anyone else? It's hard to compete after that.
It is very hard.
What she said. I was going to say something like I would get both sizes of you if I could. That's what I was going to suggest as my wisdom. But I more of a comment. It's been, this team is remote, and we've been working on this project remotely, and we're in the middle of this pandemic still, and it's I guess I don't even know how to connect it, but I'm excited about the prospect for bringing you to reality, and then especially with the star model.
All of us meditating together.
Pretty much, yeah. And dancing.
Yeah. Tom, anything you want to add?
Yeah, it's hard to follow Mingjing, but I would echo that it's been really great working with all of you guys, and it's been fun working on something so whimsical, but putting so much effort and energy and thought into it. And it's just been a passion project, I think, for all of us. And I just feel very lucky that I'm able to work on that. And I wish that for everyone else, that they can work on things they're passionate about and have more whimsy in the world.
Thank you so much. So that was it. If you have any questions, feel free to send us. And, we might do another update soon when we actually get the prototypes and can start testing them. You can also go to wisdomtruffle.com and actually sign up. And we'll send you updates, and you can pre-register. We're going to be able to actually purchase me soon. So keep in touch, and see you soon, everyone. Bye-bye.
Bye.